Hi, guys. Welcome to a brand new episode of the Clear to Send podcast. This is Francois, your host, and today I'm with Jiri. Hey, Jiri, how are you?
Hey, Francois. Very well. Thanks for having me. How are you?
I'm very good. Thank you. Thank you for
Good, good, good.
joining me. And
Oh,
I'm
pleasure.
actually happy you're with me today because we're going to talk about something called the Reduced Neighbor Report. And you've just done some testing with a couple of devices, the iPad Pro and the Pixel 6. So you're here to kind of talk about some of your findings, some of your testing that you did, and share that with us. And then we're taking the opportunity here to also talk about what the reduced neighbor report is and how did it, why do we talk about it and how does it tie with 6 gigahertz Wi-Fi. So that's pretty much the purpose of the episode for today. Before we get started, do you mind introducing yourself and telling us who you are, where you work and how you got started in Wi-Fi and
Yeah, sure.
everything
Absolutely.
involved in?
There's few things I'm involved in, to be honest. Probably way too many things. But yeah, I'm Jiri. I am a Wi-Fi architect on the enterprise networking team at Cisco in the UK. So that's kind of the day job. I'm also a member of the Cisco Live team. So when we build the actual Cisco Live infrastructure, the actual conference infrastructure, that's actually us who goes to the venue the week before we build the infrastructure, which you can then use as a customer or partner or attendee.
That's
So
interesting.
that's one of my hats. I like
Maybe you
to
can come back
deploy
and
things.
talk about that.
Yeah, absolutely. Yeah, and I guess if any of you is coming to Cisco Live in Amsterdam in February, yeah, definitely reach out on Twitter or email me or use one of the channels to ping me, and yeah, I'm happy to talk to you about that. And I guess WLAN Pi is one of my other hats. So I'm one of the kind of core team members of the WLAN Pi team. So yeah, brilliant bunch of folks, and that's kind of the night job at the minute.
That's
But
pretty
yeah,
good.
great kind of learning experience, and yeah, I really enjoy doing that as well.
So how did you get started in Wi-Fi?
Yeah, good question. So I actually used to be a Microsoft guy, so I used to deploy all those kind of small business servers and all those and Exchange servers. But I think Wi-Fi always has been a passion, and kind of started on the consumer side. Being a Wi-Fi user, we used to have a small kind of community network we built between a few neighbors. Then we built few networks for some of our smaller customers. There was kind of small company back in Prague, where I'm originally from. And then yeah, I worked for a Cisco partner, a Cisco customer, so I was kind of always interested in Wi-Fi. Then I worked for Cisco in Prague. So that was really good. And about 9 years ago or so, we moved to the UK, and I joined the Cisco team here. So I've kind of closed the loop, being a Cisco employee on the vendor side, worked for a partner, worked for a customer. But I'll pause here and let's chat about the actual technical stuff.
No worries. So I'll actually share my screen. You tell me if you see what I'm sharing.
I can see it, yes.
So this is very exciting for us, maybe not for everyone, but this is the standards. And this is a section that it kind of describes the structure of the reduced neighbor report. And the reduced neighbor report is an information element that you will find in the beacon frames and some of the probe response frames as well. So we'll see that in Wireshark in a bit. And you'll see that it has this structure. You have the element ID, the length, and then you have the neighbor AP information field, which is actually where we'll have all of the information that we're interested in. And the main goal of the reduced neighbor report is for an AP to kind of advertise to the clients that it support SSIDs mainly on other bands. And this is one of the mechanism, and Jiri did some tests, so he'll talk to us about that. But this is one of the best way for an AP to advertise a 6 gigahertz SSID. So what will happen is that the AP will include that reduce neighbor report into the beacon that is standing on 2.4 or on 5 gigahertz to let the clients know that it supports 6 gigahertz as well. And we'll have detailed about which channels they're operating on, which SSID they are supporting, and which BSSID they're supporting on 6 gigahertz inside these reduced neighbor reports. Jiri, you want to add something or makes sense?
No, that's good. Yeah, thanks.
So I have some PCAPs that Jiri sent to me. So thank you for that. I have one open here in Wireshark. And so this is just one frame. You can see this is one beacon frame that has been sent on a channel 36, so on 5 gigahertz. It's used to advertise the Cisco 5 SSID here. But if I look into the beacon frame and if I expand and look at all of the information elements, we can find that there's one that's called Reduce Neighbor Report. And if I look at it, you can see that we have 3 sections or 3 subfields. We have the number, the type, the length, and then the AP information. So that matches what we have in the standards: the element ID, the length, and the neighbor AP information. Now, if we look into that neighbor AP information field, you'll see that we're gonna get into subfields. That's what I call the inception in Wi-Fi, right? You go into different fields and you never know which level you're at. It's kind of like the movie Inception, if you guys have seen it. You go dreams between dreams. You never know if you're in a dream or the reality. But here we're going down into the information element. So I'm going down into the neighbor AP information section, and we have a couple of information about the what they call the TBTT. I think it stands for Target Beacon Transmission Time. And then so we have the TBT information, and then we have a channel number, and then we have what they call the TBTT information. And the TBTT information is the section that will contain a little bit more detailed about which SSID and which BSSID is supported on the given channel. In our case, the channel here is channel 5 on 6 gigahertz. And if the AP is broadcasting more than one SSID, you will see multiple TBTT information sections. So you'll have one TBTT information section per SSID that the AP is broadcasting on 6 gigahertz. You will know, the channel number. The operating class goes along the channel number to know which frequency we're operating on. And then the TBTT information here, they tell you information about, how many SSIDs are supported. So that's what the TBTT information count is. So here you can see we have 0, but we have 1 information. That's because the count is -1. So if you have 1, it's 1 minus 1. If you have 2, it would be 2 minus 1, and we'll see 1 here. And then if we get into the TBTT information and get a little bit more detail about that specific BSSID, you can see that we have the BSSID that we're retrieving here. So if the client is interested in 6 gigahertz, it can take that information and connect to that BSSID on 6 gigahertz on the given channel. And then you can see also that they have this short SSID information, and here it's just a way that they have to kind of convert an SSID, which is just a string of characters, into something that's more numerical. So they actually have the formula in the standards if you guys are interested in decoding it. But yeah, this is the formula here. If you're listening to this podcast, we also recording the screens. And so if you want to see the formula, you have to go on YouTube. I'm not going to spell it out for you. Sorry, but this is a way they found to calculate, I guess, convert the SSID into a numerical value.
Yeah, I guess just on that transfer, it's not that easy as it
it's
as
not
it
as
looks.
easy.
In the peak up. So I've kind of spent some time on that. So there's the kind of algorithm how you can, or the formula how you can compute it. But yeah, I kind of spent some time trying to find a tool which could decode it if there was an online tool, but I haven't found one. So I guess that might be a good kind of suggestion if someone from the Wi-Fi community is interested to build in Python or any other language a tool that will basically take the short SSID and try to decode it. That might be quite a nice exercise, I guess. Or even the other way around, if I give you the actual SSID string or the SSID name, if the tool could kind of give you the short SSID value. Anyway, sorry, interrupted you there, but yeah, it's not.
You want a SSID to short SSID converter?
That would be nice, I guess. Yeah, if someone's interested.
But maybe that's something that the Wireshark will also add to the software, right? So they can give you both. That would be a nice addition.
That would be nice. Yeah.
So this information is part of the reduced neighbor report. And so here in this example, you can see that we have one SSID on 6 gigahertz on channel 5. We also have information here inside the TBTT information. They talk about BSS parameter and they talk about the PSD subfield, which is the power spectrum density. So I don't really know where these come from. They actually don't talk about this in the standards. In the standard, the section stops after short SSID. So I don't know if that's something that the Cisco AP is adding. Jiri, I don't know if you know that.
I don't know is the honest answer. I can check, but I'm not certain on that one.
Yeah, I was just curious. Maybe it's somewhere else in the standard, but when I was looking at it, we can see the section on the reduced neighbor report stops after the calculating the short SSID. After that, they move on to something else. So it was interesting to me to see this information, but we can kind of see like that the AP is able to provide additional information about the 6 gigahertz BSS in here, which could be useful for the client to understand which power they could use and things like this. So this is an example with just one SSID. Now, Jiri did a test with 2 SSIDs, I believe, right here. And if I load this one, you'll see that it will be very similar in Wireshark. I'm loading it in Wireshark. I'm just going to collapse it all so we can go back to the reduced neighbor report. And you will see that the information that we get in the neighbor AP information is very similar, except that here we have 2 TBTT information sections. And we can see that the TBT information count is now 1, which makes sense. It's the same channel, so I'm guessing you were using the same channel here, Jiri, in your testing.
Exactly. So this was a AP Catalyst AP with the Cisco 5 gigahertz only SSID, and then I had 2 6 gigahertz only SSIDs, and the 5 gigahertz SSID RNR information was basically telling the client there are 2 existing 6 gigahertz only SSIDs on the same channel 5, actually served by the same access point. But you can see if you look at the short SSID that element is different. So yeah, there are actually two different SSIDs, and you can see 2 different TBTT sections there in the PCAP.
Yeah, we can see the BSSID is very similar, so we can guess that it's 2 SSID from the same AP. Yeah,
exactly. Yeah.
Okay, and I can guess here. I would say this short SSID stands for Cisco 6, right? Am I right?
So one is Cisco 6. The other one is Cisco 6.6.
6.
I can probably find it based on the BSSID.
Yeah, that's.
But anyway, yeah, it was just 2 kind of SSIDs. I was curious how it would actually look in the PCAP. So you basically get these 2 TBTT information sections one per 6 gigahertz SSID.
And do you get it on all of the SSIDs you broadcast on 5 gigahertz?
Good question. That's a good question. I believe that would be on all of the 5 GHz SSIDs.
It would
I
make
haven't
sense, right?
tested it, to be honest, but it would make sense to actually do it that way. And if you have, I actually tested the kind of other scenario. If you don't use 5 GHz, but you want to use 2.4 GHz for any reason, and use reduced neighbor port in 2.4 GHz and tell the 6 GHz capable client about the 6 GHz capable SSID, you can do it. So you would have one 2.4 only SSID, one 6 gig only SSID, and the 2.4 beacon. The reduced neighbor port tells the client that there are in this case again 2 6 gig SSIDs on channel 5.
Yeah, that's an interesting use case. If you want 2.4 and 6 gigahertz, but not 5 gigahertz.
Yeah. That's kind of a corner case, but I was just curious if this would work.
Well, maybe you're using 5 gigahertz for a backhaul connection, and then you need access on 2.4 and 6. Maybe that would make sense.
Yeah, I guess something along those lines.
And they also have the neighbor AP TBTT offset. I think that's the time until the next beacon. That's how I understood it, but I'm not sure if I'm right here. Anyway, so this is kind of overview of the neighbor reduced neighbor report. I wanted to show you the size as well. So it's 30. The size is 30 bytes, and you can see that it's it's going to make the beacon a little bigger for sure. But it's not that big. If you compare, beacon is around like between 300 400 bytes usually. So it adds maybe 10% of the size to the beacon frame. Okay, so what we'll do here is I'll stop sharing my screen. Jiri, if you want to take it on and give a little bit of background of the testing that you did, and then tell us about what you found out about some of the client behaviors. Because when 6 gigahertz arrived, we had like multiple mechanisms that were defined to do the 6 gigahertz discovery, and we didn't really know at the time which one was going to be implemented by the client devices. So that was kind of like what you were trying to find out, studying
Exactly.
the client devices.
So I kind of switch to the lab camera, if you will, and
that's a nice one.
We can talk tech. So what I did was I was curious how the Wi-Fi 6E capable devices would discover the 6E or 6 gigahertz SSIDs and APs. So what I did was I borrowed a Pixel 6 and I bought the new Wi-Fi 6E capable iPad without asking my wife for permission. So that was an interesting one. Yeah, it was really nice to actually see the test results and test it kind of firsthand. So what I did there was I have few Catalyst APs in this lab here. So I use the Catalyst 9136 6E AP. I've got a Catalyst controller running on a cloud, which this AP is joined to, and then I had a number of SSIDs on the controller. So what I did there was I kind of wanted to understand what happens if I deploy a 6 gigahertz only SSID, which is my only SSID, which probably is a corner case, to be honest. So
even though at first we thought, because of WPA3, we were, at the beginning, we were like, that could be a good strategy to only go 6 gigahertz in theory.
Yeah. To be honest, there's probably a better way of doing it, but we can chat about that in a minute. So that was kind of my first, I guess, corner case, pretty much. What happens if I only enable 6 gigahertz on the AP? I don't have any 2.4. I have no 5 gigahertz. Are the clients going to discover it? No problem. Happy days. All channels. PSC channels, non-PSC channels. PSC stands for the preferred scanning channels. So basically those channels are kind of designed to be discoverable or predefined to be discoverable by the clients. that was the idea.
Mm-hmm.
So that was the first test. And just to summarize, on the iPad, if you only use 6 gigahertz, there's no 2.4 or 5 gigahertz. It will basically not discover any of the 6 gigahertz APs on any of the 6 gigahertz channels. I should say I've only tested the lower 6 gigahertz, which is available here in the UK.
Mm-hmm.
So that was kind of interesting. So long story short, and I have a couple of blog posts which we can refer to in the show notes. So long story short, the iPad relies primarily and only, as far as I can tell, in the software version, on the reduced neighborhood ports. So the recommendation, and in fact, Apple's recommendation is if you want to deploy 6E, have a 6 gigahertz SSID and also have a 2.4 or 5 gigahertz SSID as well. So that's what they recommend if you want to do that. And this is the very reason.
Yeah. And
exactly.
Yeah, so I'm sharing my screen again, and I will put the link to the show notes. But I saved this link as well, where the on the support website for Apple, where they explain that they want to the iPhone or the iOS device would work better if you don't give different names for your SSIDs on different bands. And that's probably the reason why, right? If you do, then the 6 gigahertz is not discoverable.
Exactly. And I suspect, and this is kind of just my suspicion, it might actually be a clever way how to save or extend the battery life, if you think about it. So basically you scan 2.4, it scans 5 gigahertz. If I hear about 6 gigahertz APs in those 2.4 gigahertz or 5 gigahertz beacons, I might then go and have a look on that channel 5 and discover the 6 gigahertz AP on channel 5. But perhaps if I'm not hearing in the reduced neighbor reports in the 2.4 and 5 gigahertz beacons, there's probably no reason for me to kind of enable the 6 gigahertz radio almost, or do any kind of active scans. So that's kind of my suspicion, which might actually be quite clever way how to do it. Obviously, if you deploy only 6 gigahertz, that's a bit of a showstopper at the minute in this kind of software version of iOS. But yeah, I guess that might be the rationale behind it.
But we always said that we were waiting on the iPhone or the iPad to support 6 gigahertz to really, have the momentum around 6 gigahertz. But I feel like it's truer than ever, right? Especially with all of these, recommendations from Apple and the way they do it. I feel like it's going to change a little bit the ideas we had of deploying 6 gigahertz. It's going to drive some of our design decisions. Yeah.
Yeah. To be honest, my kind of goal was to understand these design decisions. So when I speak to one of my customers, what is that I have tested, I've proved, I'm happy with, confident with. So that was kind of the primary reason. It was not to bash any particular client device vendor or compare device vendors. And I guess the more I learn about this, it's actually quite interesting to kind of understand why have they done it in this way and not in the other way. So yeah, that was quite interesting on the iPad. But essentially, to be completely honest, I can't really think of any use case where I would only use 6 gigahertz today at this point in time. I guess in most use cases, I would definitely have 5 gigahertz enabled, and maybe in some cases even 2.4 gigahertz. I guess with these devices, they are 2.4 only capable still. I'm just showing my Apple Watch here if you're listening in. So yeah, I think it's not a big deal, to be honest, of using 5 gigahertz and 6 gigahertz kind of at the same time. And based on the tests I've seen, having a different SSID for 5 gigahertz and different SSID for 6 gigahertz was not a problem. The iPad still discovered the 6 gigahertz SSID from the RNR in the different SSID on 5 gigahertz, if it makes sense. So that actually works super well. So the moment you enable one of the other current bands, meaning 2.4 or 5 gigahertz, it just works like a charm. There's no problem whatsoever, and yeah, the discovery just works pretty much instantly.
Do you want to talk about the FILS as well, or fields? I don't know how you say it, but
yeah, we can chat about that. So I would say in general that the kind of recommendation, best practice, what works best is to use the reduced neighbor port. So have 6 gigahertz enabled plus enable 2.4 or 5 gigahertz or both of those if you have a use case for both. And that's kind of the best way of discovering the SSIDs in 6 gigahertz. But if you want to do in-band discovery, so in 6 gigahertz band discovery, there are still beacons. So every 100 milliseconds or so, there are still 6 gigahertz beacons, which you can look into. They're still being broadcasted there in the 6 gigahertz channel. But then if you only have 6 gigahertz enabled on the access point without 2.4, without 5 gigahertz, by default, we enable fails frames as well. So those are action frames sent every 20 milliseconds. So basically, you would have one beacon followed by 4 fails, kind of rapid beacons, if you will. You can think of them as kind of condensed beacons almost. So they have the short SSID and those kind of mechanisms, elements in them. So if you looked at a PCAP, I don't know if you have one ready, Francois, or I can share my screen and show the actual fails.
I don't know if you included the one with the fields. Let me see.
I've just found it. So let me share my screen if that works.
Yeah, I'll up.
So hopefully you can see it now.
Not yet. Oh, okay. Yes. Perfect.
Okay, there we go. So what I've got here is I've left in the beacon frames, so you can see beacons every 100 milliseconds or so, and in between them there are 4 fails discovery action frames sent on the same 6 gigahertz channel. So you can see this is channel 5975 in the 6 gigahertz band, and while the beacon as such is around let's call it 400 bytes in this case, the actual fails discovery action frame is only 100 or so bytes. So it's you can think of it as a kind of condensed 6 gigahertz beacon sent every 20 milliseconds, and the purpose of these is to help 6 gigahertz clients that are scanning the 6 gigahertz channels to kind of rapidly discover the presence of the 6 gigahertz SSID. So hence they're kind of sent much more often than the beacons. So you still have beacons, and in between the beacons, there will be 4 fails frames in between.
And that's because we have a lot of channels on 6 gigahertz, right? So it would take forever to discover everything.
Exactly. So we just waited for the beacon frames every 100 milliseconds, and we kind of did that for every single 6 gigahertz channel. That would take quite some time. So hence the fails frames. But again, they're only enabled at least on the Cisco APs and controllers. They're only enabled if your only SSID is actually a 6 gigahertz one. So if I just quickly show you the config I've got here on this cloud controller, I think I have.
Is a cloud down? Because I've heard the
No.
cloud is never down.
It is not, and it's actually more of a lab than than a kind of production service. So that's my staging controller on the Cisco D Cloud service, and at this point in time, what I've got here is I've got my 5 GHz only and 6 GHz only SSIDs enabled. So if you looked in the 5 GHz beacons, you will see the Cisco 6 GHz SSID being announced to the clients in the reduced neighbor port. But if you go ahead and disable the 5 GHz SSID and you only have the 6 GHz SSID on the air, what will happen automatically is you will start seeing the fill frames on that particular channel. So if I go and have a look at that AP, what channel it's on, 6 gigahertz radio. So this one is on primary channel 5, which is a preferred scanning channel. And what will happen there is we only have this one 6 gigahertz only SSID in the 6 gigahertz band, and there's no other method for the clients to actually discover it other than scanning those 6 gigahertz channels and looking for the fill frames.
So that's what the AP does, but it doesn't mean the as we said earlier, it doesn't mean the iPad will see them and discover the SSID.
Exactly. Yeah. So it looks to me like the client pretty much ignores them, and it relies 100% on the reduced neighbor port. So if you did this, you only had the 6 gigahertz SSID on its own on the air. The iPad will not see it. For the iPad to see it, what you could do is you can either enable the 5 gigahertz SSID or the 2.4 gigahertz SSID, or we can kind of change the we can kind of change the design, and what we can do instead is, and that's what kind of Apple recommends, to use one same SSID name for all bands. So this is just my kind of way of naming the SSID. So this Cisco 2.4, N5, N6 is actually kind of tri-band SSID, same name on all bands. And what will happen there is in 2.4 and 5 gig, you will see the reduced neighbor port information telling the client about the 6 gigahertz capable SSIDs there.
Okay, so what about the, because you also tested the Pixel phone. What did you find out about the Pixel phone? Does it discover the 6 gigahertz on the SSID?
Yeah, so on the Pixel, that was quite interesting. I'll probably help myself with this this blog post. Again, we can share a link to it. So this was Pixel 6, and I started with the 6 gigahertz only SSID, as you said, and I set primary channel 5, and that didn't work. So it pretty much did not discover any SSID in the 6 gigahertz band. And I waited for a few minutes, nothing happened. I changed the SSID to, or I actually moved the AP to a different channel, and which was a non-preferred scanning channel, and that worked. So you can see the Cisco 6 SSID being discovered, although there was no 5 gigahertz, no 2.4, no reduced neighbor port. So it looks like it actually uses the fails, and it actually scanned the channel and discovered, using the in-band fails method, the Cisco 6 SSID. I went through all the channels.
Interesting. It's interesting that it finds it on a non-PSC channel, no?
Exactly. So that's why towards the beginning of this episode, I kind of mentioned, those PSC channels are designed to be easily discoverable, but there we go. We can actually, or the Pixel can discover even the non-PSC channels. So what I did was I went through all the channels manually last night, in fact, and this is just a graphical representation of the outcome. So basically, there are some channels it can discover the AP on, and some channels it can't discover the 6 GHz AP on using the in-band scanning method.
Did you use 80 megahertz wide channels or 20?
Good question. I've tried all channel widths. So I started with 80, then I tried 20, 40, 160. It made no difference whatsoever. So basically, some channels it can easily scan apparently and discover the SSID in band. But some channels, if you put the AP there, it will not discover it using the in-band method.
Interesting.
So yeah, that was quite interesting. But I guess at least if you have 6 GHz only SSID and that's your only SSID on the air, there is a way how to discover it on some channels. So that was an interesting one. But I guess the good news is when I use the reduced neighbor port, I enabled both 5 GHz and 6 GHz. And again, I used two different SSID names. You can use the same name if you prefer. That worked like a charm. So the minute it saw the 5 GHz SSID parse the reduced neighbor port, it showed up in the scans. So you can see that we quite easily in literally a few seconds were able to see the 5 GHz only plus the 6 GHz only SSID there.
And you also have a B network and a BG. Is it related to 82.11b and 82.11b?
No, that's not. That's the home production. So yeah, that's just my kind of home SSID. So B is the production, BG is the guest SSID.
Okay.
Here.
BG means something in French, so I was wondering.
Oh, does it? Okay. But
the French people will know. The French people will know. No, that's cool.
So yeah, that was an interesting exercise to do that. We had a quick chat about the two 6 GHz SSIDs. So if you enable two 6 GHz SSIDs, you open the reduced neighbor port, what you will get is actually information about both of those SSIDs. So you can see on channel 5, we've got this BSSID, this other BSSID, and then we have two different short SSID elements there. So that's just me using, instead of Wireshark, what I did was I just took the PCAP, dragged it into Wi-Fi Explorer Pro, and it can kind of nicely parse the information and tell you what the details inside are, which is quite nice.
Awesome.
So yeah,
what we'll do? Yeah, it's. I think your testing was pretty good. Thank you for spending the time to test all of the channels and all of the channel width.
My pleasure.
I'm looking forward to do more testing on my end as well. With Roel, we're getting a couple of 6 GHz clients, so we'll do some testing for the podcast as well and share it with you guys. What we'll do for this episode is we'll link in the show notes the blog post that Jiri wrote, so you guys can go back to read them. They're quite good and they're not too long, so it will take you no time to get through them. Then what we'll do is, if Jiri is okay, we'll share some of the PCAPs. You tell me, Jiri. Yeah. Okay.
So definitely go for it. That's kind of nice to see it with your own eyes.
Yeah, exactly. In Wireshark, you can open them and study them. It's nice, especially if you don't have any 6 GHz APs, right? Which is the case for a lot of people right now. And then I'll also include the sections that you can find information about the reduced neighbor report in the standards. So if you guys want to read those sections, I'll put that into the show notes as well. So that was pretty much it. We wanted to kind of focus on the reduced neighbor report for this episode. It goes alongside with the one we did a few weeks back, and we talked about the multiple BSSID element as well. So make sure to check that out. And then as we deploy more and more 6 GHz network, we'll try to talk a little bit more about it and share some of our experience in the field for you guys. If you have any questions, feel free to reach out to us on Twitter. You can watch this video on YouTube. The show notes will be on clear2send.net. And Jiri, thank you very much for your time. It was a pleasure to have you for the first time. Maybe not the last.
My pleasure. My pleasure. Yeah, and I was going to say, if anyone has any even consumer APs at home, or you have other vendors' APs, or you want to test how that works, if the fills, for example, is enabled on your AP, that will be, I guess, quite interesting exercise just to understand how those different chipsets and APs actually behave. And I guess just to add on the WLAN Pi front, if you're using the latest WLAN Pi, so either the R4 or even the M4, they're Wi-Fi 6E capable. But the reason why I mention it is they typically scan the preferred scanning channels only. So if your AP happens to be on a different channel, there's a chance you will not discover it using the WLAN Pi, at least not today, simply because there are quite a few channels to scan. So for that reason, we scan if you use the Pi as a remote sensor, for example, with Wi-Fi Explorer Pro. We only scan the preferred scanning channel. So basically, you would have to put the AP's primary channel on one of those preferred scanning channels to be able to discover it. But basically, all the pickups I took using the Pis. So yeah, it was quite nice to actually put them to good use. And yeah, it was a great learning exercise.
Awesome. Yeah, and I use that for 60 GHz packet capture as well. And you mentioned the PSC, the AP using the PS or the client scanning the PSC. I think that the AP manufacturers, I think that's what they want. They want us to use the PSCs, right, as much as possible, even though not everyone is using them. But I mean, I think that's what I would do if I were to deploy something on 60 GHz. It would be logical to use the PSCs, but I guess we'll see.
Yeah. And I guess with 80 megahertz wide, it kind of suggests the use of PSC channels. That's kind of an easy way of doing it.
I know what you're going to tell me. You're going to tell me, yes, in Europe, we only have Uni5. If we start using 80 megahertz for channels, we're not going to have enough. So what do we do?
Yeah. I guess it depends. It's horses for courses. So I guess in a home office with a couple of APs, 3 APs, 4 APs, you can quite easily do that. When it comes to kind of large public venues, stadiums, you probably don't want to do that.
Yeah, that would be interesting, actually. Anyway, plenty of stuff to talk about. So we'll leave you guys with this, and we'll talk to you guys in the next episode. Thank you, Jiri.
Thank you so much.
Bye-bye.